Hello friends and welcome back to your own channel. Today I'm going to explain about confusion matrix very clearly like never before. Before we begin, if you have not liked this video, please hit that like button. Also subscribe to the channel and that will give you 10 years of good luck. Believe me, it's true. Let's begin. What is confusion matrix? It is an error matrix for comparing different machine learning models. Let me explain this to you with an example. Let's say you are working for a pharmaceutical company and they provide you with a data set of patients. Your job is to predict whether the patient has cancer. Now, you will build different models to do this task. Let's say you build 3 different machine learning models. And now you want to compare these 3 models to check which one performs better. A confusion matrix helps you to find out how accurate is your model in making predictions. Wait, but how? Let's say your model will predict for each patient 1. The patient has cancer, or 2. The patient does not have cancer. However, in reality, the patient may have cancer or the patient may not have cancer. So there could be 4 different scenario arises. Let's say in reality or actual case, the patient may have cancer or may not have cancer. And you predicted that the patient has cancer or does not have cancer. By this way, we get 2 by 2 matrix. Let's understand all 4 scenarios in detail. Now, the first scenario, in reality, the patient has cancer and you predicted that patient has cancer. This is called true positives. This is perfectly fine. This is correct prediction. Let's see scenario number 2. Here, in reality, the patient does not have cancer and you predicted that the patient does not have cancer. This is called true negatives. This is also perfectly fine. This is also correct prediction. Hence, there is no error. Let's see the third case. Here, in reality, the patient does not have cancer, but you predicted that the patient has cancer. This is called false positive because you falsely classified this patient as having cancer. Now, this is error. Let's see the fourth scenario. Here, reality is that patient has cancer, but you predicted that the patient does not have cancer. These are called false negatives because you have falsely classified them as not having cancer. This is also error. So, you have true positives and true negatives, which are perfectly fine. But you also have false positives and false negatives, which are errors. And you will always have some errors in your predictions, in your models. So, your objective is to increase true positives and true negatives, while to decrease false negatives and false positives. What do you think? Which one is important in this case? Is it false positives or false negatives? Let's see. Although false positives are errors, but they are okay in our case since they do not have cancer. The cost is overtreatment or carrying out one more test for identification of cancer. But in case of false negatives, this is real problem. We can't afford them here. because they are actually having cancer and our model predicted that they don't have one, and it costs lives. So remember, you had developed three models. Now you will compare all three models on this confusion matrix, and you will choose the model which has lowest false negatives, provided other values are same or at least in comparable range. Now, can you identify a case where false positives are more important? And coming down below, there are other performance metrics too, like recall, precision, sensitivity, specificity, F1 score, ROC, AUC score, and lift score. And I shall make a separate video on these measures to explain them in more detail. But for now, thanks for watching my channel. Bye-bye.